All right. Today we are going to learn how to use the completing the square method to solve quadratic equations. Now, why we use the completing the square method is because not all quadratic equations are factorizable, and also is by the completing the square method that we even derive the quadratic formula that can solve all quadratic equations. So that's also meaning that completing the square method can also be used to solve all quadratic equations. Now, we're going to go through the steps quickly so you can learn how to solve every quadratic equation by completing the square. The first method, or rather the first step, is to make sure that the coefficient of the squared term is 1. So, as you can see in this example, the coefficient of s squared is not 1, rather it is 2. But any other question you're solving and the coefficient is 1, you can skip this first step. Now, since the coefficient is not 1, we just want to divide everything by that 2, which is the coefficient of s squared. So that's what we have. When we do this, see that these two can cancel out. So we have s squared now plus 5x over 2 plus 1 over 2 equal to 0 divided by 2 is still 0. Now, having done this first step, the second step is to rearrange. So we need to move this constant term to the other side of the equation. So doing that, we have s squared plus 5x over 2 is equal to negative 1 over 2 because it's going to become negative. Now, the last step that we need to take in order to complete this square, because we're saying that when we complete the square, what we're doing on this side of the equation is that after completing the square, it must be a perfect square trinomial, and then we can easily factor it. So to do that, you need to take half the coefficient of x. So what is the coefficient of x? It's simply the number that is multiplying the x term, which of course you can see is 5 over 2. So we're going to take half the coefficient of 5 over 2. Having a number is just multiplying by half. So we have 5 over 2 times half, which is 5 over 4. So we're going to now, having half the coefficient, we're now going to square it. So we're going to raise it to the power 2. And then we're going to add this number to both sides. So we have s squared plus 5x over 2. We're going to add it. So let me use another color for that. So we're adding 5 over 4 all squared to both sides. Now, having done this, what we have on the left hand side is now a perfect square trinomial. And if you have watched my video on perfect square trinomial, which if you've not, I'm going to put the link in the description, discover that to factor a perfect square trinomial, it is simply the first term, which is x, and the last term, which is 5 over 4, and then the sign that is in the middle term. So factoring this quickly would be x plus 5 over 4 all squared. That's how to factor a perfect square trinomial. And then for this other side, we can go ahead and simplify. This is 1 over 2 plus 5 squared is 25, 4 squared is 16. So let's simplify that one further. The LCM of 2 and 16 is 16. 16 into 2 is 8. 8 times minus 1 is minus 8. Plus 16 into itself is 1. Just have 25. Then minus 8 plus 25 is the same as saying 25 minus 8. So that's going to give me 17 over 16. And remember, it is still x plus 5 over 4 squared here. So all we need to do now is to eliminate this square, right? And you know that to eliminate square, we just have to take the square root. So let's take the square root of both sides. We'll now have x plus 5 over 4 is equal to the square root of 17 over 16. So this is going to be x plus 5 over 4. Seeing that 17 is not a perfect square, we can just apply the law of sorts by distributing the square root to the numerator and the denominator. So we now have x plus 5 over 4 is equal to square root of 17. Since it's not a perfect square, square root of 16 is 4. So finally now, and don't forget, you need to take plus or minus for the square root, all right? So I'm going to put it there because we are going to have two values for x. Then we have now that moving 5 over 4 the other side, we have it is equal to positive 5 over 4 become negative 5 over 4 plus or minus root 17 over 4. So let me just finalize my